This video is about exponential and logarithmic inverses and inequalities. This is AP Precalculus topic 2.13. If you appreciate this content, please give it a like. Example 1. To find the inverse of a function, you switch x and y, and then you solve for y. F of x is basically y. So when I switch x and y, I'm going to have x is equal to 3 times 2 to the y plus 4 power minus 15. Now I just need to solve for y. Let's start by adding 15 to both sides. So we get x plus 15 is equal to 3 times 2 to the y plus 4 power. We need to isolate the exponential part of this equation. So let's divide both sides by 3. We get x plus 15 over 3 is equal to 2 to the y plus 4 power. We can cancel out a base 2 with a log base 2. So let's take the log base 2 of both sides of this equation. On the left side, we now have the log base 2 of x plus 15 over 3. On the right hand side, the log base 2 and the base 2 cancel each other out, and we are left with y plus 4. We are trying to get y by itself, so now we just have to subtract 4 from both sides. So that will give us the log base 2 of x plus 15 over 3 minus 4. This is basically the answer, but since the original function was called f, we should call the inverse f inverse with a -1 superscript, like this. Example 2. Again, to find the inverse of any function, you switch x and y, and then you solve for y. G of x is basically y, so I'm going to switch x and y by putting x in the front. So we have x is equal to -3 log base 5 of y minus 4 plus 6. Now we need to solve for y. But the first stage of the solution is to isolate the log expression. So let's subtract 6 from both sides. We get x minus 6 is equal to -3 times log base 5 of y minus 4. To further isolate the log expression, let's divide both sides by -3. So we get x minus 6 over -3 is equal to log base 5 of y minus 4. We can cancel out log base 5 using a base 5. In other words, we can get rid of the log base 5 by exponentiating both sides of the equation with a base 5. All of this is up in the exponent, by the way. On the left side, we have this wacky expression 5 to the x minus 6 over -3 power. All of that is the exponent. On the right-hand side of the equation, the base 5 and the log base 5 cancel each other out, and we have y minus 4. We are trying to solve for y at this point, so we just need to add 4 to both sides of the equation. So we are going to get y is equal to 5 to the x minus 6 over -3. And then to all of this, we will add the 4. This is basically the answer, but because the original function was called g of x, we should call the inverse g inverse instead of y. So this is the inverse of function g. Here's another version of the answer that I'd like you to be able to recognize as correct as an option on a multiple choice question. The reason why these are the same is because if you take x minus 6 and factor out a negative sign, then that becomes negative x plus 6, and this is the same thing as 6 minus x. So when I went from x minus 6 to 6 minus x, I generated this extra negative sign, which canceled out the negative sign in the denominator of the x. Example 3. Let h of x equal 3 to the x plus 1 power minus 2, and let k of x equal h inverse of x. For what values of x does k of x equal 1? They are asking where k of x will equal 1, but remember k of x is h inverse, so they are asking where h inverse will equal 1. For inverse functions, the input values and the output values are reversed. So h at a will equal b if and only if h inverse at b is equal to a. So h inverse at x will equal 1 if and only if h at 1 is equal to x. So we can find this x value by simply evaluating h at 1. So let's go. H at 1 means plugging in 1 for x. So h at 1 will equal 3 to the 1 plus 1 power minus 2. So h at 1 will equal 3 squared, which is 9, minus 2, which equals 7. Quick recap. We just found that h at 1 is equal to 7. We are trying to find the value of x where h inverse at x will equal 1. But this will only happen when h at 1 is equal to x. But h at 1 is 7, like I just said. So that means x must equal 7. Example 4. Let f of x equal the log of x squared minus 4x plus 7 minus the log of x plus 3. What are all the values of x for which f of x is greater than 0? To solve an inequality, it's often useful to have a sign chart. However, to make a sign chart, we first need to find where f of x is equal to 0 and where f of x is undefined. Let's start by finding where f of x will equal 0. That means finding where all of this is equal to 0. Let's solve by adding the log of x plus 3 to both sides. In other words, let's move this expression over there. Once you have two logs equal to each other, you can solve by setting the arguments, or the inside part, equal to each other. Let's get 0 on one side by subtracting x from both sides, which will leave x squared minus 5x, and subtracting 3 from both sides, which will create plus 4, is equal to 0. This one is going to be factorable. Sometimes we have to use the quadratic formula or the graphing calculator, but not yet. X squared will factor as x times x. 4 can factor as either 2 times 2 or 1 times 4. Looking at this middle term, it's going to be the 1 times 4. Inner plus outer must equal the middle. To make a middle of negative 5, we need a negative 1x inner and a negative 4x outer. Also, notice that negative 1 times negative 4 does equal positive 4, so it makes sense. Using the zero product property, setting each one of these factors equal to 0, we get x is equal to 1 and x is equal to 4. Take a moment to make sure that neither of these values are extraneous. In other words, make sure that neither one makes a 0 or a negative number when you plug it back in, because you can't take the log of 0 or the log of a negative number. 1 and 4 both make positive expressions here and here when you plug them in, so these are fine. These are the first two values that will go on the sign chart later. Next, we need to discuss where f of x is undefined. starting with where the argument of either of these log functions will equal 0. You can't take the log of 0, so f of x will definitely be undefined where x squared minus 4x plus 7 is equal to 0, so we'll have to deal with that. F of x will also be undefined where x plus 3 is equal to 0. That will be a lot simpler. But let's deal with this one first. I would love it if this was factorable, but it is not. So we will have to solve using the quadratic formula. X will equal the opposite of b, so that's positive 4, plus or minus the square root of b squared, 16, minus 4 times a, which is 1, times c, which is 7, all over 2a. So all over 2. At a glance, we can tell that this equation will have no real solutions because under the radical we have 16 minus 28. That's a negative number. That's going to be imaginary. So no real solutions here. F of x will also be undefined when x plus 3 is equal to 0, which means at x equals negative 3. So this is another critical value that will go on the sign chart. So far we have 3 critical values to put on the sign chart. So here are the critical values across the top of my sign chart. We need to figure out whether f of x is positive or negative in each interval. In the first interval, I want to use negative 4 as a test value, but let's jump right to here. If I plug in negative 4, that's negative 4 plus 3, that's negative 1. You cannot take the log of a negative number. So f at negative 4 is undefined. In the next interval, let's use a test value of 0. We can do this mentally. If we plug in 0 for these x's, that just leaves the log of 7 minus the log of 3. This is going to be positive because this is bigger than this. So we'll put a positive in this interval. In the next interval, let's use a test value of 2. So plugging in 2 for these x's, we'd have the log of 2 squared, so that's 4, minus 4 times 2, so that's minus 8, plus 7. I'll simplify this later. Minus the log of 2 plus 3, which is 5, of course, but I will save that for the next step. 4 minus 8, that's negative 4, plus 7, that's positive 3. So we have the log of 3 minus the log of 5. This is negative. So we'll put a minus here on the sign chart. Finally, for the last interval, let's use a test value of 5. So this will give us the log of 25. Plugging in 5 right here would give us minus 20 plus 7 minus the log of 5 plus 3. So let's see. 25 minus 20 is 5. Plus 7 is 12. So we've got the log of 12 minus the log of 8. This is positive. So let's put a plus right here on the sign chart. Remember, we are looking for where f of x is greater than 0. So the solutions will be in these intervals where f of x is positive. F of x will be greater than 0 on the open interval from negative 3 to 1, union 4 to infinity. Notice that if they had asked where f of x was greater than or equal to 0, then we would have used brackets on the 1 and the 4 instead of parentheses. The negative 3 would get a parenthesis no matter what because f of x is undefined at negative 3. I am going to declare example 5 calculator active. So we will use our graphing calculator as needed. Let g of x equal the natural log of x squared plus x minus 5, and let h of x equal the natural log of x plus 4. What are all the values of x for which g of x is less than h of x? By subtracting h of x from both sides, the inequality can be written as g of x minus h of x is less than 0. Let's define f of x as g of x minus h of x. So we are trying to find where f of x is less than 0. Ultimately, we would like to make a sign chart for f of x, but in order to do that, we need to know where f of x is equal to 0 and where f of x is undefined. To find where f of x is equal to 0, we will set g of x minus h of x equal to 0. Adding the natural log of x plus 4 to both sides of the equation gives us this equation. If the natural log is equal to the natural log, then the argument on the inside must equal the argument on the inside. Subtracting x from both sides, these x's will cancel each other out. So we will have x squared. Then subtracting 4 from both sides gives us x squared minus 9 is equal to 0. This is factorable as x plus 3 times x minus 3, which gives us x is equal to negative 3 and x is equal to positive 3. These two values will go on the sign chart later. Now we need to find where f of x is undefined. You cannot take the natural log of 0. So f of x will be undefined when this expression inside the logarithm is equal to 0, or when this expression is equal to 0. Let's solve this equation first. I would normally factor this if I could, but x squared plus x minus 5 is not factorable. Instead, we can solve this equation using the quadratic formula. X will equal the opposite of b, so negative 1, plus or minus the square root of b squared, and b is 1, so that's going to just be 1 squared, which is 1, minus 4ac, so minus 4 times 1, which I won't write, times c, which is negative 5. All over 2a, that's 2 times 1, which is just 2. So this gives x is equal to negative 1 plus or minus the square root of. Negative 4 times negative 5 is positive 20. So this is really 1 plus 20. This is 21. Let's go ahead and use the graphing calculator to get decimal approximations for these two solutions. I'm getting 1.791 and negative 2.791. So that's two more values for the sign chart later. F of x will also be undefined when x plus 4 is equal to 0. In other words, when x is equal to negative 4. Now it's time to make the sign chart using these 5 critical values. Write your 5 critical values across the top of your sign chart from least to greatest. Let's use the graphing calculator to help us decide whether f of x is positive, negative, or undefined in each one of these intervals. Let's type this expression for f of x into the graphing calculator as y1. When you have it all typed in, it should look like this. I need you to change one setting on your calculator. So hit second window for the table setup menu. Right here where it says independent auto, I want you to change this to ask. Go to here and hit enter. Now hit second graph to go to the table. Because we switched it to ask mode, the calculator will evaluate f of x at whatever x values we pick. In the first interval, we need to pick a test value that is less than negative 4. For example, negative 5. However, when we type in -5 and hit enter, it says error. Why is that? f of x is undefined at -5 because you cannot take the natural log of a negative number. And when you put in -5 right here, that's -5 plus 4, which is -1. So any value less than -4 is going to cause f of x to be undefined. So for the next interval, we need to pick a number between -3 and -4. So let's do -3.5. -3.5. And all that matters is that this is a positive number. For the next interval, we need a number between -3 and -2.791. These numbers are very close together, but if we pick a number like -2.8 or -2.9, that will work. I'm going to type in -2.9. And we get a negative value. Next, we need a test value between -2.791 and positive 1.791. Well, 0 is in between there. Looks like we have another undefined value. Let's see if we can figure out why. f of x is undefined at 0 because if you plug in 0 right here, these x's are basically gone, and you are left with the natural log of -5. You cannot take the log of a negative number, so that's why it is undefined. Next, we need a test value between 1.791 and 3. So how about 2? That's a negative number. Finally, we need a test value bigger than 3. Let's use 4. That's giving us a positive answer. We are looking for the values of x that will cause f of x, which is this expression, to be less than 0. So the solutions will be in these intervals where f of x is negative. These endpoints are open circles because we are looking for where f of x is less than 0, not less than or equal to 0. So we will use parentheses and not brackets when we write the solution intervals. So f of x will be less than 0 on the interval from -3 to -2.791, union the interval from 1.791 to 3. Be aware that if we had been looking for where f of x is less than or equal to 0, then the -3 and the +3 would have gotten brackets. However, the -2.791 and the +1.791 would still get parentheses. That's because these two values are where f of x is undefined, and undefined values will never be included and should always get parentheses. Example 6. Let k of x equal 1 minus 4 times 2 to the x minus 3 power. What are all values of x for which k of x is less than or equal to -31? Finding where k of x is less than or equal to -31 means solving this exponential inequality. Let's simplify this by isolating the exponential part of the inequality. Let's start by subtracting 1 from both sides of the inequality. So we will have -4 times 2 to the x minus 3 power is less than or equal to -32. Be very careful now. I want to divide both sides of the inequality by -4 to isolate this part of the expression. However, when you divide both sides of an inequality by a negative number, you have to remember to reverse the direction of the inequality. So dividing by -4 will leave us with 2 to the x minus 3 power on the left side, but then we will have greater than or equal to +8. Ultimately, we need to get x by itself, but first we need to somehow make this 2 go away. We can get rid of that 2 by taking the log base 2 of both sides of this inequality. Log base 2 and base 2 cancel each other out, leaving behind the x minus 3 on the left side of the inequality. On the right hand side we have the log base 2 of 8, which is 3 because 2 to the third power is 8. Finally, we can get x by itself by adding 3 to both sides. That gives us x is greater than or equal to 6. And that's the answer. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.